Hi, it's Gadget UK here again, a bit of a review kind of video here, and some of the build of a TF1260. So it's an 060 accelerator board for the Amiga. This is an 030. This will be another video along with another one of these TerribleFire boards. That'll be another video, three more TerribleFire videos coming your way soon. Now, I think I lost some footage. I wasn't planning on sharing the entire build, but I did originally show all of the components and things at the start, so I've lost that footage. But anyway, I'm going to jump now to having shown you the board partly complete. You've got all the little small SMD components and things on there. Compared to something like this, this was far easier to build because the components are a lot bigger. They're like, I don't know, 1208s or something like that, whereas on the TF1260 they are 0603, which is like the size of a grain of salt. They're so small you can hardly see them without magnification. I filmed very little of this just because I've done so many similar builds in the past, although this one has got the finest pitch compared to other things I've done in the past. But nevertheless, I thought I'd share some bits of this with you. So we're nearing completion now. I've got most of the components on there, all the caps and really small components. We're just doing the chips, 5 chips here. These are 245s. I'll start on this corner over here because I anchored that one and anchored that one. You're not going to be able to see because it's so very small pitch, and we'll just have a bit of slow drag along there. And if you get any bridges like we've got down there, just use a bit of additional flux perhaps, remove the solder from your tip. Give it another drag. If that doesn't work, just use a little bit of braid. But yeah, that's not looking too bad, just a bridge in this corner here. Right, trying to get the last RAM chip on and then onto the CPLDs. So I'll just flow crazy amount of solder there. Just try flow that one pin. That'll do. That's a giant blob. Doesn't matter. It's the biggest one I've had on the board so far, actually. It's a consequence of trying to do it on camera. And a little bit there. So, I don't know if you can see that. A couple of blobs just holding that in position. I'm using magnification. You can't do work like this without magnification. It's impossible. You don't necessarily need a microscope. You can just use like a little magnifier with a stand. You know, that's what I got. My parents bought me that years ago, actually, as a gift at Christmas, I think, one year. So I'm very grateful for that. It's helped me out no end on a lot of these assemblies. So I just add a little bit of solder and have a drag along here. I'm going a bit slower because this iron doesn't transfer the heat very well. A little bit more solder. We are going to end up with a giant blob on the right hand side here. That is for certain, like that. That's huge. Anyway, you get the idea. So I'll do the same thing on the other side, use a bit of braid to mop that up and then just reflow it, make sure it's nice and clean and there are no shorts. So far this has taken an incredible amount of time. I've done this in bits, and I'm talking like, you know, over, I don't know, space of 6 different days, spread out over about almost a month and a half, 2 months actually, just because my health has been so blooming bad. I don't want to go on a bit too long. I've had high calcium in my blood and low phosphates, which is a bit concerning because that can be one of the things you get when you've got cancer. But yeah, my vitamin D's been super low as well, so maybe that's a factor. Those things will have a relationship to each other. But anyway, as a result of that, I've not been able to do very much. I've done this in bits. You know, I'd spend an hour just putting a load of caps, because look how many caps there are on the underside. Small things, there's absolutely millions of them. It took blooming ages to get those caps on. Yeah, but thankfully we are nearing the end. Still got the custom, because this is unique to the special edition board. An array of LEDs here and the circle on the underside. I fitted one there, but anyway, I need to do all the other ones. Those are really hard to do because they're kind of like BGA mounted. You know, they're totally surface mounted. There's no pads at the side to solder them. You've got to get the solder on there, heat up with hot air, and it'll float into the right position. Anyway, I'll get the toothbrush onto this in a bit. I'm not going to do that just now. I'll just clean the majority of the flux off this way. And get the clock multiplier on next. And finish off with the CPLDs, then the sockets and connectors and things. Sorry, it's starting to rain here. But anyway, we're on the home stretch here. Just got these 2 CPLDs to get on there. And then the sockets and connectors. And we are done. can see you need very little solder on these, otherwise you just get huge parts where it joins like that there. Granted, there's perhaps not as much flux on that side as there are on the others. Try and remove that solder. So I'm about to go and test this. The first thing I want to do actually is just measure to make sure we've not got any shorts. So on the 5 volts and ground here, yeah, we don't have a short. We have some resistance, but bound to, we've got things across it. Between 5 volts and 3.3 volts, nothing. Between 3.3 volts and ground, yeah, no short there. So I'm going to go power this up. I'm going to take the multimeter. I'm not going to have the processor in to start with. I'm going to measure the 3.3 volts on here, you know, between ground and 3.3 volts. All I'm going to do, I've got a cable, you might have seen it on the TF330 build. I'll stick a link up there to that, because it's the same. That's why I've skirted through showing you the whole build on this, because other than the 0603 components being quite small and have it in different connectors and things, it's more or less the same kind of process. The thing I'm not sure about is whether I've got the right crystal on here, have I got any bridges anywhere. Yeah, so I don't know. Anyway, so I'm going to just power this, measure the voltage, and then we'll see if we can program it. Let me just do a sanity check on the ground connection actually, just to make sure that the grounds are correct on this. So the ground is the bottom there, that's ground. One side of that should be ground. And I think if we test from that ground connection to the ground pin on one of these, yeah, that's definitely ground. So I've got my wire here, you can see I've got a positive on one side, negative on the other. It wants to go this way around. Let's just make sure nothing is getting hot. Yeah, always a good idea. Switch the multimeter to volts, and yeah, it's a bit fiddly to do this. That was a ground there, so I'm going to measure from there to the centre pin. See that? 3.27 volts. Yeah, hopefully you can see that. 3.28 volts there. So it is outputting 3.3 volts roughly, where it should be doing. Now the other thing I'm going to do here is just disconnect the power, and I'll just feel under here. That's the switching regulator. There are a few hairs on this actually since I've just carried it through. We'll clean those off in a minute. Anyway, all signs are it's okay. So I've got my Xilinx programmer here. You can see I've got one of these things on the end. Sometimes those are useful if you've not fitted thing there. You can just plug it in, just wedge it at an angle, and generally it will make a good connection. I've got a hair on there, look. So just looking at how this is wired. So I need to get some magnification here so I can see what these things say here, but I'm guessing they're going to be in the same order there, and I can just literally pull that off and clip it on. Yeah, so it goes TMS, TDI, and 3.3 is on the end here, so the order is exactly the same. So I need to pull that off and then carefully connect that like that. Those are all separate connections if you kind of squeeze them together the way I just did. Now this is not connected to the PC at this stage. I want to connect power up first, being very careful to get this the right way around. Just do a sense check again. So this is the Xilinx programmer. Let's plug that into the USB. So I've double click boundary scan, and then we'll choose right click initialize chain. It's kind of a moot point, this part of the video really, because most people wouldn't be building one of these themselves, because it's kind of a closed project at the moment. That might change in the future, but at the moment there's only 2 or 3 people building these. You know, Stephen himself has built a number of these and kindly given them to friends and stuff. But there's also, I think, Supaduper Mark is building them, and Chucky, John Hurtle. So I need to find the JEDEC for the first one. So the order you've got to do these is RAM, then bus. There are 2 for the RAM here. There's one for 6 nanoseconds. I'm guessing that's if you want to go faster. So RAM first, then bus. So if we select the RAM and then click open, and then select bus and then open. So they're both assigned there. Let's just click OK. And then we should be able to program these both up, so fingers crossed we don't get any errors. I don't see any bridges or anything on there, so yeah, that one's alright. Let's do this one, program. Okay. Excellent. So at that point we can now get the processor on there and plug it into the 1200. Now I'm assuming that jumper there has to be on to enable it. It's just to say enable. This is a cost reduced one, you know. It's got an MMU, I think. It's 68LC60RC50. So if that's genuine markage on there, it should run at 50 megahertz as a minimum. Let's just inspect the pins. This has been tested previously. I tested this on the 4060 card actually. So where's pin 1 on this? I can't remember. I think it's up here. I think that's pin 1. And pin 1 on here I think is here. Of course you can inspect here too. Yeah, you can see I've got 3 pins there. Hang on. Yeah, I've got a gap in the corner here, a gap down there. We've got 3 pins in the middle there that kind of go with that row there, and then 1, 2, gap 1. So that would correspond. So I'm confident that that is the correct way around. So I don't just ram it in and do, you know, alternate maybe, because you see it's not on this side very well. So let's do that side first maybe. There we go. That's looking better on all 4 sides, and then squeeze it in. It went straight in. No issues at all. So let me go and connect it up to the 1200. I hope it works. There is an issue with the LC CPU though, because there's no FPU. AIBB, you know, the benchmark there, and Sys Info, they just kind of crash. They won't benchmark it properly. Now that's a kind of software thing. I can work around that. It might take me some time. I think what I'm going to need to do is build a custom Kickstart ROM that has got a couple of math libraries fixed, so they're done within CPU rather than depending on the 060 FPU that isn't there. But as you can see, it's working. All the games and things I've tested on this work fine. I'll test Doom. I'm interested to see how well Doom runs on this. Can't run Quake without an FPU, and I can't run any of the 060 demos. I mean, I can show you some of those on the A4000, but you'll have seen those in a previous video. I could always invest in a full 060 for this, an R6, but you're looking between £250 and £300, which is a lot of money. And I've got 2 of those already. I've got one in my 4000 and one in the Atari Falcon. I don't think I can justify spending another 200. Well, I don't even know whether I can find £250 to buy one. That's the problem. But yeah, I'm very pleased though for what I'm going to be using this machine for. The 1200. It's my main gaming machine, but I can run demos and things on the 4000, I guess. Silky smooth. So without a doubt the best way to use an 060 is the full one with the FPU, but we've now got patch versions of these 2 benchmarks, so let's do a speed test. And wow, that is staggering, 37363. So if you compare to the bottom there to an 040, it's twice as fast. I mean, it's kind of logical because it's running at 50 megahertz and the 040 benchmark there is 25, so yeah, it's just a bit more than twice as fast as a 68 040 running at 25. That is brilliant, absolutely amazing. The interesting thing is it says there's an FPU and it says in use. This is just because it's been patched. There isn't an FPU, but there is an MMU. Now I'm not sure the MMU is working correctly, because if I do a drive speed check, I've got MMU libs installed, and if we do a speed test, it's coming back about 1.3 meg, which is pretty slow. Now I can't remember, I don't think I've ever benchmarked the IDE on this 1200 actually, so that could be to do with the compact flash card I've got in there. Got no idea, but yeah, it's coming out a bit low, that, isn't it? If I do quit, but that is probably my IDE. Now if we go into which Amiga, that should tell us more or less the same thing. Yeah, that's more correct, because there's floating point unit not available, but the memory management unit is running. So that's looking good there. Got 3 versions there, strangely enough. Yeah, now that's detecting the CPU running at 14.3 megahertz. I'm sure that's not the case at all. Let's do a memory test, see what that comes back at. Yeah, so that's staggeringly impressive, isn't it? It's equal to almost the 3000 there, running at 25. It's twice as fast roughly as a 4040 Let's just try integer math. Yeah, look at that. That's super fast. Super fast. It's weird how it comes back with the clock running at 14.3 there. We know it's not, because obviously the performance there is staggering compared to these other things. Yeah, so that will certainly do me. I'm going to play this for quite a while now, I think, most of the week probably. Let's just try Doom on this. I've put a different version of Doom on here. Hopefully this will work. Hopefully I'm not going to get hampered by the lack of the FPU. I don't think it uses the FPU, to be honest, this one. So we'll do PAL low res. I'm not sure if you can get like the demo on this. I think it just goes around the title screen there, doesn't it? New game, knee deep in the dead. Yeah, that is pretty jerky actually. Let's just increase the screen size. So I stuck some 3M thermal adhesive on top of the CPU here. Yeah, very tight space to work in here because I've got the keyboard precariously balanced. That's one thing you need to be careful of, because if you pull the keyboard off or it falls off, you'll damage the membrane. Just get the corner of that. There we go. So yeah, this is 3M stuff. It's really good. Yeah, that should do. So I'm going to put 2 there. So better than nothing. It obviously would be better if you've got one solid heatsink rather than 4 small ones, but those will stick on there and stay stuck on. I could always get a fan at some point. I've got some small fans. I could probably just about fit a fan on there within the case, I think, because the keyboard is going to go down here like this. I just need to just check, is that pressing on it? Yeah, that is a problem. The clearance means you can't even get heatsink on actually. So, not sure what to do about that. And there we go. So we've got heatsink on that CPLD, heatsink on this one, some dodgy heatsinks here, and some tape. And the drive is just going to sit like that. Now there is enough room to, push this up like that there. This will get flattened down by the keyboard. There's nothing conductive here, so that should be okay. It does mean that you've really got to kind of take the lid off to get this out, because you've got nothing, to grip on the underneath of the card here, other than the SMD caps and resistors. You just end up breaking them off. There's a hair there, look. I haven't finished this board yet anyway. I need to take it out, give you a final close-up of the work that I did there, and I need to get the LED arrays on both sides. We've got that one LED, but I need to do the remainder of those. Anyway, that should be okay. You can get vented, let's just move that up a little bit. Yeah, you can get like a vented slot for the bottom of this, 3D printed, so I might fit one of those. I just need to just test everything now to see if it all fits. So one of my wires here are no longer used actually. I had a wire originally to switch between 33 megahertz and I think it was 26 or something like that, or 22 it could have been. Now I've got to thank supaduper for sending a compact flash image to me actually to help me get around a problem I was having. The TF tools, and I can show you this, doesn't run on my standard 3.1 setup, and I've got 2 compact flash cards here that are both vanilla 3.1 installs. That's the driver, by the way, for the additional compact flash interface there, the EIDE interface. It's a work in progress, so I think the idea is that will go up to PIO 4. In terms of speed, it should be very fast, but it's a work in progress, so I don't know whether it's standard PIO mode at the moment. So it takes quite a lot longer to boot than normal, because obviously I've got loads of drives here. I've got 2 compact flash cards, at the same time, one provided by the TF1260 IDE and one by the Amiga 1200's own IDE. But the good news is everything works there now. If I run TF Tools and set the speed, in fact I can show you that, and we go to TF Tools, TF Tools again, CPU speed, and I'll just double click this. You'll see it pops up and it shows there, and you can see there it shows CPU speed 50 megahertz and the serial number. Now on the other compact flash card that doesn't happen, I can show you that, it just crashes. And I've tried everything, I mean absolutely everything to get it to work. So I don't know what's different about this. This is like classic Workbench, isn't it? There's some additional patches and things on here. Now Stephen said there's no reliance on anything, there's no prerequisites, it's a standalone executable, it doesn't need anything else in the system, but clearly there's a difference between vanilla 3.1 and this that it works with. So there is some sort of requisite there, I don't know what it is, but as I'll show you, I've got two 3.1 installs that are just basic vanilla 3.1 installs with nothing else applied to it, and it doesn't work. So I don't get it. Spent almost 2 full days messing around trying to understand the cause of that problem, and I still haven't got to the bottom of it. But if we just get a command line up, and if I go into TF Tools, I can do the same thing actually. There we go. DIR, and we do CPU speed equals 66. Now this is the thing I'm still learning about here, I'm not sure. You can see it says nearest clock speed is 62.5. Now if I was to go to say 70, let's try and get 70, you'll see it's still 62.5. So there are quite large steps there. If I try to go to the next speed up just by going, you know, up to 70, I think 75, it suddenly changes to about 72. You know, if you set 75, it'll jump up to the next step, which is about 72 or so. But then it just freezes. So my processor is not up to that. It's only a Rev 4. It's not like a Rev 6 or anything. And that's going to be the issue there. So I'm happy to get 62.5. It's amazing, absolutely amazing. So this is by the same people that make TimeGal. You can tell it's another one of those, you know, video CD. In fact, it's not video CD. It was Laserdisc, wasn't it? Laserdisc game conversions. But of course, you can play this on a standard 500. You don't need an 060 to play this. It's just something worth testing to see if the you know, it's working from the IDE, because it just hits the IDE continuously. So the switch I had on the back for switching the clock speed, I've changed to just move that over, and it reaches to the enable jumper. You can see there, booting from floppy. Can you see it's back in A1200 mode, and in memory, just 2 meg. So all the memory has been removed. So just reassembling this, something interesting that I've just discovered. The power LED, I think, is used as the LED for the internal IDE. I think, I'll be wrong. Because if I just run something from the hard disk here, just keep an eye on it, and I'm like launching it now, it's starting to load. See that? And that's not just the filter, mind you, the filter would have changed that. Look, it's gone off again, flashed it again. That is really cool actually. And the reason I noticed that is because when I first booted it, this was flashing. So the next thing I'm going to do is fit the remainder of these LEDs here. And in order to do that, I'm going to cap and tape off the side of the CPU here. 2 or 3 layers. I don't want to heat the CPU or the socket. I have ordered another CPU. I'll perhaps show you that within this video. I can get 62.5 megahertz out of this, which is great, but I'd like to get up to 75 if I could. And that incidentally is the next step up in clock speed. So the way I have chosen to tackle this, because these are completely surface mounted, I'll give you a macro in a minute. I'm going to turn up the pads here like this, get sufficient solder onto each of the pads. I will inspect it just to make sure I've got sufficient, and then just sit the component on and heat it with hot air, wait for it to suck itself down into position, and maybe use a tool as you're heating it like that just to touch it, move it, wobble it, just to make sure it is in position, and then it's just a case of trying to inspect as best you can. So here we are in macro, so you can see I've got some blobs of solder there. I'm not sure if I've got enough, I think so though. But yeah, just for size comparison, look how big my thumb is. These are tiny, tiny little things. And obviously you've got to get the orientation right. So I think I got that first one correct there. Now that doesn't illuminate at the moment. And you may be wondering why. You would think if this is, you know, if that was correctly soldered on there, it would work. The serial. I think Stephen used the analogy there. They're like Christmas tree lights. They're all in series. So, you know, there's a serial connection between this one and the next one and the next one and the next one. So the chain ends over here. And then the CPLD on here. I think, I'm not sure how he's doing it, but he must be taking one of the clocks and dividing it down. And then you know, running along here and then looping it, going back that way. It's like a counter. Got a counter thing going on that just counts up and down like that, so you get like a nice Knight Rider sort of thing. I'm not sure how this one works. Does this one just go around in a circle, or does it go one way and then the other? No idea. So we'll do that one after we got the first one done. They might even be in a continuous chain. I hope they're not. There might be two separate 8-device lines there. I'll show you on the other side when we do the others in a minute. You can see they've fitted them all though there. So I just tested this and it doesn't do anything. Now I wondered if there were 2 chains or 1 chain. If there's 1 chain, then obviously you'd need to do both sides. So I've asked Mr. Leary, and he's got back to me and said, yeah, you need to do the ones on the other side as well. So it's one serial chain, the way these are all set up, which kind of makes sense. You're utilising only 1 or 2 pins, I would presume. It's probably like a clock and the you know, serial. Not sure how many layers these boards are. I'm expecting at least 4. You know, for the speed it's running at and stuff, you wouldn't be able to get away with a 2-layer board for something like this. No way. So we'll have a little bit of scrub around here as well. I'm very pleased with how it's come out though, considering I built it myself. You know, my skills, you might think I'm great at this sort of thing, but this is, I think, maybe 20 or 30% harder than the other things I've looked at, you know, TerribleFire boards, the 536 and stuff. Everything just feels smaller on this. Well, it is. A lot of the 0603 stuff that I didn't really show. I lost some footage at the start. I was going to show you all the components and things at the start, and then show you once I'd fitted all the caps and things and resistors. And I seem to just lose the footage. I don't know where on earth it's gone. I can't find it, which is why this video has not really been a full build video. It's just been highlights, really. There is a small component there. Did I knock that off? No, I didn't. This is the thing, you've got to be careful. If you get stuck on a resistor array or a cap or resistor there, it'd be really easy to pull the thing off. And we'll do this side, so we'll just have a bit of a wipe around here. The underside on this really does need a bit of a clean because it's not had a thorough clean yet. Now this one's going to be a little bit more challenging. Well, probably not. I think you just need to work out where the first one is, and then, you know, the orientation shifts at an angle, doesn't it? But the pin out is exactly the same, so as long as you get the first one right, all the others should be right, as long as you maintain the orientation correctly as you rotate. So you can see straight away the hot air, oh my goodness, is blowing around. In fact, I need to move, oh god. So the ground and the VCC are down here, and you won't be able to see this from here, but the component has got like a larger part that comes down to the left and a tiny little bit on the bottom there, and the bottom bit is the ground and the VCC. So if I just kind of squeeze that off, you see, sticking to the tool. This is one of the things I hate about working with small components like this. I guess if you use a plastic tool you might be alright. There we go. Just get that into position. It's probably going to blow away now, so yeah, I might block the shot a little bit here. I'm just going to try and just hold it a little bit until it's warmed up a little bit. Just move it across a tiny bit, there we go. And then heat this area. The best way to do this is to do a few of them at once. Maybe even all of them at once. You know, just work your way around once this has gone on. Move the next one into position and do that one, because the board will already be, oh, don't move, at temperature. Yeah, so once it's at temperature you can literally just touch it and it should bob back into position. And that is doing. So I think that one's done. I'm just going to press it down. To make sure all the pins are soldered. That one's on. So it's just a case of repeating that for the other 7. Well, they're all blowing around. Wonderful. I think that's it. So hopefully this is a final look at the board here, so we'll have a bit of a close-up here. You can see it's looking pretty good. It looks good with the black crystal, actually. The the final thing I've just done is, where's it gone now? Fitted the 3-pin fan header, and I've tilted it inwards. Can you see that? Because obviously the keyboard comes down here like this. Now it doesn't quite contact that there. Obviously there's no space here for heat sinks, but yeah, it could be a bit tight when you've got a connector on there, so just tilting it inwards a little bit should help with that. But hopefully you can see, other than some slightly large blobs on those there, it's looking pretty good actually. Yeah, black PCBs never come out that well because, you know, in the right light you can see it looks a bit bitty and a bit streaky, but actually it's not bad. It's better than that TF330 I built that was black. You can see the regulator module there. Stephen did a mod to that actually. They come with some clamping diodes, I think, and if something goes wrong, those diodes can actually kill things. So Stephen did a mod to actually remove those diodes, and I think that's probably a good thing to do. I think it was something that Motorola recommended or something. I think he'd seen it on the original documentation for this. So yeah, I'm very grateful. Stephen has done an absolutely amazing job. Yeah, 106 megahertz. Obviously you need to get the right processor, and it's going to vary. Your mileage is going to vary depending on the rev of your 1200 and the processor you're using. But yeah, I'm pleased with the results there. It's come out pretty well. You know, the solder points on those CPLDs aren't bad actually. It's probably equally as tidy as that TF330 was, I think. Yeah, some large blobs of solder on here though. Can you see that? Just in the right angles you can see it look a bit blobby, but I'm not going to mess with it. It looks good and it works. And the reason it boots twice is because the first time it's loading that EIDE drive and then it reboots. Now I'm not sure if you can boot from that EIDE card, but nevertheless it works really well. Can you see how many drive icons I've got here? I've actually got 3 compact flash cards there, believe it or not. Yeah, there's a master and a slave in the 1200. And never had those working properly in this machine actually. It suddenly dawned on me I needed to go into HT Toolbox, and I needed to change the drive IDs on the slave, you know, the labels or whatever they are, the names, from DH0, DH1, 2, etc. to something else, because I had 2 compact flash cards in there. That's why I always had that switch on the back, and it was like that from when I got it. So anyway, I've got all 3 working together. The ones with the old icons here are the primary and secondary, you know, master slave on the 1200. In fact, that's not how I've got it configured actually. I've got the slave, what was the slave of the secondary drive, on the EIDE interface. So I think that's this one here actually, Road. So I've got Road Avenger, Scum VM. I could probably show you some of those in a minute. But I've got an absolute ton of games there. Absolutely incredible the amount of space I've managed to get here, because I've obviously got 3 compact flash cards now. But anything that runs on the 030 or less will run absolutely staggeringly fast on this. Just periodically I've been testing temperature here. It's just like lukewarm, and this is overclocked at 62.5. Now I have ordered a 66 megahertz chip for this, so I'm going to have a go with that. Perhaps by the end of this video I might have swapped to that, and we'll try it at 75. But yeah, everything's running nice and cool here. It is a good idea to heatsink these things, definitely. I did the same exact thing on the TF536. So I've spent a lot of time messing around trying to think of different cooling options for this. I've seen people use, you know, laptop GPU and CPU fans. They're quite thin and they fit flat, and then they've got like a little vent on the side, so you could do that. I've seen a few fitted here, sort of like pointing diagonally, because, you know, obviously you've got to keep it within the profile where the keyboard comes up here, so over here you've got more space. But you can just about see I cut the pins half as long, and then I bent them all over, tested it out with the keyboard just fits nice and flush. It pretty much touches that plastic connector, but this one here is inwards compared to here. Now I'm not sure if I'm on the switched pin here or not. We'll find out in a minute and test it. But you can see the location I decided to mount the fan is here. Now what I want to do is I want to take air that way. I want the fan to pull air that way, because you've got the vents above here, so air in theory should come up and hot air will rise. So airflow, you can see I've changed the orientation of these, air should flow this way. And I think because I've not got the thing on the underneath here, you know, the cover, and you can get the ones with the holes in, air should get pulled up from the underneath, I think, basically. So I mean, you could argue these might be better the other way around, because the air is going to get sort of pulled this way. In general, because this is going to be pushing air out of the top of the case, air will just come in from wherever. So it should be okay. This does not get very warm anyway, but you know, we're going to try and fit a 66 megahertz one on here and run it at 75 if we can. So the way I'm going to mount this, there's no easy way. You could 3D print something, you could design some 3D print something to fit there. That would be really nice, you know, a mount that maybe just wedges in between in that gap and has a couple of points to put screws in. That would be quite cool for something like that. I don't know what dimensions that is. It looks like literally 2 centimeters by 2 centimeters roughly, something like that, maybe 2.5. I'm going to get, I've got a sticky double-sided sponge. I'm going to stick it down on the shielding, but at the same time I'm going to get some down the side of the drive here, and it's just going to fit like that there. The two things together should hold it. It's not very high RPM this, but that should mean it should stay in place. And there we go, that's stuck onto the drive and onto the chassis. Because it's stuck on two things at the same time, as you can see, and it's a bit spongy, there's a bit of flexibility there. The vibrations are dampened, there's no sound, it's silent, and it's blowing air this way, so I can feel air very gently being sucked this way. Obviously that will increase when we've got the lid on, so I'm happy with that. That's alright. This wire's not too bad, it's not going to interfere too much. So the other thing I'm going to do while I'm just finishing off here, this has got nothing to do with the accelerator at all. I'm going to stick some tape around the sides of these LEDs, because you'll know what it's like if you've got one of these. When they flash, it blurs into the other ones, if you see what I mean. So like when the hard disk LED flickers, you can sort of see a bit of a glow in one of the others. So I guess if I just if I can cut this tape thin enough and into a couple of strips, I can just mask these off from each other. That's all I'm going to do. Stick a piece of tape like down there. It's not easy said than done. Yeah, I want to get it sat quite down a little bit like that. Let's give that a try. So I need to put this back on here now. I'm not sure which way around it went now, actually. I think it went that way, actually. Yeah, you can see there, that looks alright. You can't see the red tape, and maybe it looks a bit red, I don't know. I'll give it a try and just see if that works. Yes, that solved the problem. If I switch it on now, you see that one there? When this is green, this would be illuminated, but it's not now. Only illuminates, and that the same here. These two are not bleeding into each other, as well as the power not affecting that either. It looks like it's sunk down a bit there. Actually, I might just make sure that's screwed in properly. So as you can see, it's not all illuminating. None of the LEDs on the other side are illuminating. I'm assuming this LED here is the issue, so I'm going to try and reflow that, see if that makes a difference. Hopefully the rest will then illuminate. And as I say, there are none illuminated on that side. You can see the light bleeding through here, through that little gap, but none of these are illuminating. But I think these follow that, so that might explain it. So I'm not sure if it was a bad solder joint or damaged LED or what, but as you can see now, that is working there. The sweep option, fantastic. Doesn't that look cool? Obviously this would be better with a clear machine, but I guess the silly thing with this really, you can't see it because you won't have a clear keyboard, that's for sure. As you can see there, that is working. So it was just, I forget which one it was now, I think it was that one. The LED, I just swapped it for another. The solder pads all look good, so I think it was on there properly. The only thing I did for good measure was reflow this one, so I'm going to keep that other LED. It may be okay, I don't know. But anyway, I'm very pleased with that. That's the final piece of this now. I can now start to reassemble it. So I'm swapping over here to the RC66, it's an LC CPU again, with the aim of hoping I can get 75. It looks like it might be an R5 or an R6. I didn't like bending and cutting those down for the fan header, but there really was no alternative. Now this is really well sat down, so it's going to take a little bit of experimentation to get my PGA removal thing under there. You know, at the moment there's no gap at all. What I might have to do is use something like a knife, just perhaps on a corner or something, just to prise it a little bit in order that I can then get this in there. Is that going to go in? Almost. There you go, it's in. Once you get one bit done, you can then do another bit, and then as you go round it, it should get progressively easier. It's weird that, isn't it? How you do one side and then the other side starts to come up, because they were totally flat before. Obviously this extra bit of tape we won't need on the one I'm going to fit in. I'm just going to fit the heat sinks slightly nearer to the middle, but you know, with a big gap here, otherwise it will interfere with the keyboard. Obviously the more gradual you do this, the less chance of bending any of the legs. Pull out now, I think. There we go. So no bent pins or anything. Let's just stick that back there. So that was the 50 megahertz one. It looks slightly different colour, the surface to this as well. This is like a more of a bluey. I've forgotten where pin 1 was already now. It was down here, wasn't it? Yeah, that's right, because the writing's up there like that, and it was this way around. So let's just inspect the pins here, just to make sure we haven't got any that are well out of alignment, and there aren't. So that looks good. Let's get it into position. You've got to kind of get a feel for the thing before you start to press it down completely, because if, like here, up here, there's some pins not going in. You can see that there. Can you see that one? Second one? Yeah, and if they don't go in, you'll just mangle them when you squash it. This side feels alright. It's just that side up there. Maybe get that side in first. Gonna need to inspect this, because somewhere around here something is not correct. Right, just straightened about 4 or 5 pins there, and I think that's going to go in. It kind of looks like it. You can see that went in a little bit. Let's just try and do it equally on each side, and then you'll know if you get stuck. Yeah, there you go, it's in. Make a nice smooth sliding entry. Anyway, so pin 1's right. Let's just get a couple of heat sinks on. So we're all connected up. So I've had 100% success on boots on this. There's no failed boots or anything like that, and it's rock solid stable. I've run this for long periods of time and not had an issue. Now the only exception was when I did a live stream showing the TF1260. I was trying that Laserdisc game, what's it called, Road Avenger I think it was, and it froze, didn't it, on that one part or something, then it reset. Now I think that was a temperature thing, because at that point I'm not sure I had all the heat sinks and things on that I've got on now, but I've used it for hours and hours, you know, very long periods, and not had a single issue with it. So you can see I've got a clock there. That will be the next video, and something else as part of that as well. But we've got 128 meg of fast RAM and 060 report up here. So if I go into a couple of benchmarks, I'll show you what the performance of this is like. We'll do AIBB first. You need the latest version of MMUlibs as well. I think 4, along with Stephen's help, did some modifications to it so it supports the 060. So as I showed in my live streams, it reports 14.3 megahertz. Now Stephen's going to do a change to the firmware when he has some time, so that doesn't happen. At the moment, when it's accessing chip RAM, I think it slows the clock speed down to give the processor, you know, the 68060 time to cool, which was quite a clever idea, but in practice doesn't really, you don't gain much, I don't think. I think he realised it was a good test to do, but I think he's not happy with that, so he's going to revert it back so that it should show the proper clock speed here when that new firmware is out. But if I do, let's do an integer math. But look at that, that's right up there. It's incredible. We covered the 040 in my 3640 build there, and the performance of that was staggering. Well, look at how much faster an 060 is. It's because it's superscalar, you know, it's got that same sort of technology the Pentium introduced. So yeah, staggering integer math for the memory test. You can see that's still pretty good. A4040, obviously, as I mentioned in previous videos, is bottlenecked a little bit. You know, an A3025, yeah, it's not massively faster there, is it? Considering that's on run at 25 megahertz, so we're running at 62.5. But you know, you're obviously going to have a limitation on memory. You can only go as fast as you know the bottlenecks will allow, and it might not necessarily just be the CPU when it comes to things like that. Let's do Beach Ball. So this is Beach Ball without an FPU, and you can see that is very quick. That is incredibly quick. Do speed. Yeah, so it's quite staggering again. 46711 dry stones. Reports some things on here. Instruction cache is on, data cache is on, instruction burst is on, data burst is on. copy back is off. It's interesting how these benchmarks show different things. AIBB showed iBurst off and data burst off, so it's really weird that. And you can't switch them off and on here, but I do know he's got burst mode working. That might be in the very latest firmware, where he's made a performance improvement on it. It's significantly faster throughput and stuff there on the memory side of things with the latest firmware that he hasn't released yet. But if we look at drives, you can see I've got a crazy amount of drives here because there are 3 compact flash cards. So that first drive there is coming up 1.673, as you can see. If I can go to, where's the next one, DH0. Now this is the EIDE interface. It says there actually, EIDE. It's not EIDE, it's EIDE is the driver. And look at that, 1.9 meg, so it's faster already. Now this is without the PIO mode stuff that Stephen has been working on. He's trying to go for PIO mode 4. So that will be a firmware update as well, and then the other drive is the other drive on the 1200s, interface. It's just using SCSI.device, and that's going to be about 1.6 meg. So straight away, the new IDE interface on there with the crap compact flash cards I'm using, it's faster, getting about 1.9 meg. Look, 1885. So that's very good. So when that compact flash card is accessed on that interface, it flashes the power light, and what it's doing is switching the filter off and on. Now that was a really clever idea, but at the same time that creates a problem. If I load a game with music, that plays music in the background, as that light is flickering off and on as it's streaming the data in, as it's loading, you hear the music playing. Certainly when you've got headphones on, you can hear the filter going off and on as the LED is flickering. So I've asked if we can get the author of that driver to maybe do a mod at some point to make it configurable, whether you want the LED to toggle on off there to indicate drive access, because I think that's not a good thing personally. It might be alright if you've got data on that drive, no games and things, it wouldn't be a problem, would it? But if you're loading games like I am, and I'll show you that. So hopefully, as that was flashing there, you could actually see and hear, the hear filter going off and on as that was flashing in sync. The other thing I want to point out while we're here as well is on the previous video, this LED I mentioned is on all the time. It's when I did the repair of this 1200 actually. Now, having swapped the compact flash cards around, so one of the compact flash cards that was originally in the 1200 as a slave, I think, that's now on the EIDE interface. It solved my problem completely. And I think it's the compact flash card itself. I did mention within that video I thought it might be the compact flash card. Some compact flash cards drive that LED on all the time, and it might be as a result of a fault, but having had them all juggled around now, I've still got the original compact flash card in there, but it's on the other interface. We don't have any issues, and interestingly enough, it doesn't cause an issue on this interface either, other than obviously, we've got the filter thing going on there, but that's the driver. So yeah, my hard disk LED works correctly now. It's not on all the time. That only flashes when either of the internal, onboard motherboard interface drives are accessed. So if you've got a full 68060 in there with an FPU, obviously you can run anything, any of the 060 software, but I haven't got that here. We'll demonstrate that when we look at the TF1260 in an upcoming video. I can't run the demos. Anything that's been compiled for the 060, or most things that have been compiled for the 060, will not run. So, this accelerator is kind of aimed at people who want something faster than an 030 and not too bothered about being able to run 060 demos. And that's what it comes down to, really, because other than that, there's not much else you would want, that's compiled for an 060. You've got things like PC ports of certain things, and most of them you can run on here, but some of them you can't, like Descent, for example. And in actual fact, you probably need an RTG, retargetable graphics interface to be able to run some of those, high-end PC ports anyway. So you're really not missing out on anything. But yeah, the demos, you can't run the 060 demos, but as I say, we'll look at those later. But that extra performance allows you to do all sorts of things, including play Mp3 files. I'll show you. So you can see we've got like a port of Winamp there. This one's called Amiga Amp. And if I click play, find my media, Fantastic. So being able to play MP3s like this is just amazing. And if we load another one, let's just do eject. Very cool. So yeah, it is amazing being able to play MP3s. Now, of course, you know, it downsamples them. The actual sample rate is quite low. I mean, it says 44 kilohertz there. It's not. It's going to be 22 kilohertz per channel. It might be a bit more than that because it's running on a machine that's capable of going faster on the sample rate there. Because there's supposed to be a limit of 22 kilohertz, isn't there, on Paula? But you can go a little bit beyond it with the AGA chipset, certainly. You can go like 14-bit resolution and stuff as well. So yeah, it doesn't sound quite the same as it would. You know, it's not CD quality by any stretch of the imagination, but it sounds amazing. It's just amazing being able to play MP3s on an Amiga. And if you've not already seen it, the Plitbox video, you can obviously browse the internet. Now, you can do that on an 030 or an 020, but performance-wise, you know, using a browser, something like iBrowse, especially when you're dealing with SSL connections and things as well, something like, you know, an 060 like this, as you'll have seen on the Plitbox video, it makes it usable. It's still slow. It's not, you know, it's not the sort of first point to go to access the internet by any stretch of the imagination, but to use it to tinker around and browse, and, you know, just browse a few basic websites and go to Aminet on here to download things directly to the Amiga, it's quite nice. And there's things like that Infinity Music Player, whatever it's called, a module player I think it is, that you can load as well. And there's probably plenty of other software that you could use that's internet enabled on the Amiga. But with an 060, that just makes the machine respond a lot better. It's just much far better suited than something like an 020 or an 030. And I tried to demonstrate this game on the live stream, actually. I've just let this go through the intro, and this is the key. I found that, I don't know why, it could be a glitch in this version of the game I've got, that if you let it load all the way through the intro and then start the game, it works. If you try and skip the intro, it bombs when it loads the main game and gets stuck on the last couple of loading bars, I think. And if you start a new game, yeah, this is the point where it will fail and hang on that second from last bar if you don't let the cutscene play all the way through. There you go, you can see that's working fine. So again, this is a game that obviously benefits of higher clock speed and stuff, 060. It might take advantage of the FPU, I don't know, but yeah, you can see this is, it's like Grand Theft Auto, isn't it? This was, you know, an Amiga version of that same sort of game, really. It's the same idea. You know, you've got all these cars you can steal and stuff and drive around and crash and do all sorts of crazy things with. Oh, and they got run down then. And besides those things, you can also run things like Scum VM. Now, this is obviously going to be much faster on a faster processor again. So the faster you can get your 060, the better. And again, I think with an FPU, it may even, you know, gain some performance from that. There's obviously newer versions you can run with an FPU as well. This is the slightly older one, 1.5.0. Can't run the newer ones because they're built with the FPU in mind. Not that it uses it, I think it's just compiled against a standard, you know, full 060. Anyway, if we load one of these, let's do Salmon Max. The speech on that one works fine. So you can hear we've got speech there.
Friends? We've only gone out together 3 times, and already you're telling me you just want to be friends? You never gave me a chance, and for that... you'll fry like a pork sausage.
So yeah, it's a little bit slow, a little bit clunky, but you know what, it's totally playable. If I try and skip this, I forgot what you press now, try and skip the intro here. So yeah, you get a little bit of a slowdown there, definitely.
Another confused census taker?
But some of that might be the IDE. Again, when we get PIO Mode 4,
Another idiotic and baffling assignment.
that will make a huge difference, I think,
Does it
actually.
involve wanton destruction?
But it's very cool being able to play this game on the Amiga. It really is.
Due to the arbitrarily sensitive nature of the mission, we'll be meeting a bonded city courier out on the street.
Yeah, you can't see very well because it's a little bit overbright. You can see the movement is not very fast because I've not got the settings right. You can actually run forwards and backwards pretty quick, look. It's a little bit jerky. I don't know why I have this problem every single time with this game. I have to set its executable bit there, and then the next time I load it, it works. Anybody got any ideas what that is? Why would I have to do that? I mean, it's running from the compact flash card. Maybe it's because it's formatted with FAT32 or something, or FAT whatever it is. But anyway, you'll see. Yeah, ad-lib music again. Not sure if the mouse is enabled here. Oh, it is. Yeah, it took me a few seconds to work out controls there. You can use the keyboard to go forwards and backwards. But you can see, that is more than playable. That's just like playing on a 486 or something back in the day. So yeah, Spear of Destiny is just the same as Wolfenstein really. It was the follow-up, wasn't it? Descent, you need a full 060 for that. These things came from Alan actually. I'm appreciative of Alan for sending the compact flash card he did to me. alenppc is one of the guys that builds these cards, along with supaduper and a few other people I think. Yeah, it was thanks to him I got some of these things because he sent me a card that just helped me out. Heretic, again I think Heretic needs, we'll try it. I think Heretic needs a full 060. Yeah, with Heretic won't work on this, and it's worth me showing you this error. I think if you try and run an executable that's been compiled, against needing the full 060, this is what you'll see. You'll see this, that 8, the number of zeros and a B on the end. That is a very common error that occurs when you try and run, let's say, an 060 executable. It just won't run on here because it's not got the FPU. I'm not going to show you much more here. I'll show you what Doom runs like in a second. But I also thought it was worth just showing you the tools that Stephen's provided and stuff. So, you can see them there. You've got CPU speed, fan control, light control. The light control is applicable only to the special editions, and I think there's only about 10 of those or 20 of those in existence. So most people won't come across that, I don't think. And the sweep is the same. That's how you get the light sweeping from side to side. But CPU speed is where you set the CPU speed, and there's a couple of shortcuts here that came with this setup. So you've got 50 MHz, 62, 75, 100 MHz. The 62 is actually 62.5, but nevertheless these have been set up that way, so I can double click that, and it says up here CPU speed 50 MHz, and I can do 62, CPU speed 62.5 MHz. But if I do 75, even with this RC66, you'll see it's frozen. Look. Frozen. So this 66 MHz chip I have, I suspect it's a fake, and it's actually a 50 MHz chip, and they've marked it as a 66, because if it was a genuine 66 it would probably have no trouble running at 75. That said, they all vary. There's that much variance between these from manufacture. You can just look out. It's a bit of a lottery. You can see there it double boots. Yeah, it's a bit of a lottery as to what you get with some of these 68060 CPUs. But in general, if you get an LC1, it's going to be fine at 50, and you'll probably get 62.5 out of it without an issue. Anything beyond that is a bonus, really. Now, I'm not going to show it within this video, but I have ordered an RC75. It's an EC chip, I think, so it should be lacking the MMU. So if I might look out, it might have an MMU. If it hasn't got an MMU, I'm obviously going to then lose some performance because the ROM won't be cached by MMU lib in Fast RAM. So it's a trade-off. Will the 75 MHz clock speed be better? I might even be able to go beyond it. If it's a genuine RC75, I may be able to go up to 80 something or beyond. There could be a trade-off, is the point I'm trying to make. The loss of the MMU lib could detrimentally affect performance, and it might not be worth it. I might end up sticking with what I've got here, 62.5. But it's a bit of a gamble, and that was like, I think, just under £40. It's an alternative part number. It's not marked 68060 on it. It's marked something else. It's a rare Motorola. It's a rare Motorola chip. You'll see that in another video. I'll cover it in some of the video. Sounds a little bit loud there. Yeah, I'll try and use the joystick as well. It's one of these joystick and mouse. So yeah, you can see it is crazy fast, really smooth, really playable. As fast as you perhaps could get on the Amiga, really. Yeah, you're at the levels of 4860 X266, aren't you, or beyond? I'm wrapping up here now. So heat sinks work really well, my fan works really well, it pulls cold air this way. What I might do in a later video is just test with the fan the other way round, so that the airflow, instead of being sucked this way, which is going to come up from underneath the trapdoor, because I don't have the flap there at the moment, because my theory was that the air would come up over here, you know, up from underneath, over the tops of this blades and go that way. But I don't think that's happening. I think what's probably happening is the air's coming up from around the edges of the card here, you know, and a lot of it's going around the CPU. So as you'll see, well, you can see now we've got a thermocouple. That'll be the next video. There's a hair there, look. I don't think the airflow is optimal with the way that fan is set up at the moment. I might try and flip it the other way around so it's blowing this way, because that air will definitely get over here. It's just a question of how does hot air then get out, you know, because the way it is at the moment, the hot air can, in theory, get sucked up this way and out the top of the case. But I will do some temperature tests later when I change the fan the other orientation and see which works best. But the way things stand at the moment, this gets to about 47 degrees under load when it's been on for about an hour. When you first switch it on, it's around 26 degrees, and it takes about 45 minutes to an hour to gradually climb up to about 46, 47 degrees. More often than not, the fan seems to keep it around the 46 degree mark, but I've seen peaks at 47. And if you saw my Falcon 060 video, you'll know that that's not too bad. In the Falcon, when I had a really good heatsink with a really good fan right on top of it, the Falcon I had up to 100 megahertz, and that was showing around 47, 48 degrees, and that was when it was super cooled. So I think it would be fine that way. There's a bit of a mark there on that cable, look, but it's a scratch, I think. One thing I would advise with this, and I'm going to do this as well when I revisit, desolder the 3-pin connector, have 3 wires coming off going to, you know, that in a bit of heat shrink up here. Andy Tricklebank did the same thing actually on his, and it makes more sense because when the keyboard's in here, it presses on this. Can you see the board is sunk down a bit here? It hangs down a little bit anyway. Obviously I could stick like a rubber foot or something on the back of it, and then when I stick the, you know, a flap on the underside, the cover, it would hold it in position properly. One thing you can get there, and I think Andy's done that on his, you can get a 3D printed trapdoor cover that's got little gaps in it. But for the moment I've just left the trapdoor cover off to try and get more air, because the Amiga stands off the table because of its feet, so it's just assisting with a little bit of airflow. So an amazing special thanks to Stephen Leary, Mr. TerribleFire. He's excelled himself on this. This is just amazing. I love it, absolutely love it. You know, he sent me the PCB and the socket, and then I sourced the parts with his help there. He gave me a bill of materials, and obviously he's entrusted me with the firmware for this. I've got the firmware for my version, the serial numbered as well. So yeah, don't be asking me for the firmware because you ain't going to get it. But I'm very, very grateful for Stephen's taking his own time, you know, to design this and to build this, and then to do a run, because after all of the upset that he had with the 536, you know, somebody, I don't know if you're aware, someone copied the 536. It was going to be an open source thing like the other stuff, you know, that Stephen's created have been, you know, they've been open sourced. 330 and all the source code was going to be made available, but somebody saw the need to copy and clone the board and then start selling their own, which is ridiculous because the boards were cheap as things stood. It is crazy that someone would do that, especially to someone like Stephen who's given so much of his time and his life here for us. You know, it's all of his spare time for, you know, the last number of years, bringing these accelerators to the Amiga. I never thought I'd see an 060 that's affordable in an A1200. I didn't think this would be within my, you know, affordability, my price range, because a lot of the time, if you look at, you know, the Phase 5 ones and some of the other third-party 060 accelerators for the 1200, they are crazy price. I'm talking like 500, 600, 700, 900 pounds. Those are the sorts of prices I've seen for the, you know, third-party ones that sell on eBay. So yeah, these are, don't get me wrong, these are still expensive. You know, it costs you 40 to 50 pounds for an LC CPU, and the parts, as I mentioned when I did the live stream of the testing of this board here, it cost me about 150 to 160 pounds ish, I think. It might have been a bit less than that. It was probably, if you removed the extra resistors and capacitors that I ordered, it was probably about 120, 130 pounds just for the parts. That didn't include the PCB. Stephen provided that, and I already have the Kel connector. That would have been an extra, I don't know, 7, 8, 9, 10 pounds perhaps. Sorry, it's not Kel, is it? It's different on this one. But in any case, yeah, you're probably looking at 250-ish, the cheapest for something like this. Anyway, I do hope you found the video interesting. If you would like to support the channel, please see the Ko-fi and Patreon links down below. Catch you in the next video.